Hi, Cha.
Morning. Morning. Okay, can you see the questions on the screen?
Yes, Cha.
Okay. This is the one I gave you, right? We'll be discussing today.
All
Yep.
right.
Okay.
Okay, so who is not here yet? Vinyan and Rohingya. Okay.
Yes.
We'll give a couple more minutes and we'll start, okay?
Okay, Cha.
Okay, good morning everyone. Today we finished our syllabus. So we will be going through some revision questions, okay? Has everyone tried these questions?
Yes, sure.
Yes, Cha.
Okay, we're gonna go through it, okay? You can mark. If you have any questions along the way, you can ask me, okay?
Okay, sure.
Okay, so let's look at this. Okay, a man uses a wheelbarrow to carry some logs along a flat path. He pushes with a horizontal force of 140 Newton and the wheelbarrow moves 39 meters. State the relationship between work done, force, and distance moved. Anyone?
Work done equals force times distance.
Okay, correct. So when they say relationship, basically they're asking you, okay, like, is there a formula or anything that equates this or connects these three things? So the formula is work done equals to force times distance moved. Okay, so you just write that work done equals to force times distance moved. Okay, next one. Calculate the work done moving the wheelbarrow. So from the previous formula, work done equals to force times distance removed. So now calculate the work done. So you take the force times the distance. So what do you all get? You just have to multiply the force, which is 140 Newton, and the distance 39 meters. What do you all get?
1,460.
Sorry?
5,460.
Yep, 5,460. What is the unit?
Newton meter.
Newton meter, or you can also put there joule. Okay, so either one I will accept. Okay, let's look at the next one. So here you can put the answer. Here is joule, but Newton meter is also the other unit. But since they use joule here, you use joule. State how much energy is transferred to the wheelbarrow.
5,460.
Yeah, it's the same amount of energy, 5,460, because that's the force that is being put to move the wheelbarrow. Okay, so 5,460. Okay, everyone okay so far?
Yes.
Yeah, sure.
Okay, the man stops and holds the wheelbarrow horizontally as shown. Okay, the man exerts a total upward force of F Newton, we don't know. The weight of the loaded wheelbarrow is 470 Newton. Mark X on the diagram to indicate the center of gravity of the loaded wheelbarrow. Okay, who would like to try? You can write on my screen. So you have to mark X on the diagram.
Is the pivot the mark X?
Are you wanna the pivot as in like where the wheel is it?
Yeah.
No, that is not the center.
Then so is it the triangle thing at the bottom beside the?
This one?
Yeah.
No.
So is this arrow going downwards?
Is it that?
Yeah, but you mark the X in the center on the top because you have to mark it on the object. So correct, it's this going down, but it's at the top here. So that is the center. They're asking center of gravity. Center of gravity is usually in the middle of that object. So in this case here, and because the force is going downward at this point, so X is here, the one marked here. Okay, that is the center. And it has to be in line with the arrow because the arrow is the force of gravity lah. So the center of gravity is right above it. Okay.
Yes.
That will be your center of gravity. Okay. Now let's look at the next one. Okay. State the equation linking moment, force, and perpendicular distance from the pivot. What is the equation?
Moment equals force times perpendicular distance.
Correct. Moment equals to force times perpendicular distance from the pivot. Now, when you write equation, right, and they have given you this, they ask you to link moment, force, and perpendicular distance from the pivot. Okay, when you write down your formula, you use the exact same thing. So moment equals to force times perpendicular distance. Write the whole thing, perpendicular distance from the pivot, because that's what they've given you. Same thing with the previous one. You use what they've given you. You use the words, exact words that they have given you.
Okay.
Okay?
Yeah.
The moment equals to force times perpendicular distance. Okay, calculate the force F.
So is it 201.43?
200 what?
201.43.
Yes. So how do you do that? Who is it, Nicholas? Can you explain how you did that?
0.6 times 470 to get to 182. Then 282 divided by 1.
Wait, can you explain that again? Can you say why you took those values? Explain again. Okay,
So
everyone,
moment is equals to force times perpendicular distance. So I took 0.6 times 470 multiplied by 470 we get 282.
okay.
Then 282 are divided by 1.4. Then we
Why you
equals
divide by 1.4?
0.6 plus 0.8. They get 1.4. Then 282 divided by 1.4, you get 201.43.
Yeah. So basically, right, calculate the force to lift it up. So the force that is pulling it down must equal to the force that is pulling it up, basically. Okay, so if we look at moment is equal to force times perpendicular distance from the pivot. And this is the center of gravity here. It has 470 Newton. Okay, that is pulling it down, the weight of the load. Okay, so moment is equals to force times perpendicular distance from the pivot. Okay, so if you look at the first one, for the force for this wheelbarrow at the center here is force times perpendicular distance. So force, which is 470 times 0.6. 470 times 0.6 is equals to 282. Okay, and then 282 282 is equals to, okay, again, moment equals to moment. Force times perpendicular is distance. So if we look at the force upward here, the one that is going up, we don't know what the force is, but the distance from the pivot now is this whole thing, 0.8 plus 0.6, which is 1.4. And then I calculate F. How I calculate F? 282 divided by 1.4. Okay? Anyone did not get that or does not understand? What is the unit for the answer? Newton, huh? Because force. Okay. If you all don't understand, please let me know. Huh? No, I will continue. Okay, let's look at number 2. Photograph shows the hammer just before it hits a nail. Mass of hammer 0.5. When it hits the nail, the hammer is traveling downwards with the velocity of 3.1. What's the relationship between momentum, mass, and velocity?
Momentum equals to mass times velocity.
Correct. Momentum equals to mass times velocity. Calculate the momentum of the hammer.
1.55 kg per second.
Yeah. So you just take mass times velocity. Mass 0.5 times 3.1. Okay. 0.5 times, which is the formula that you used, that you stated at A1, 2A1. So 1.55 kg meter per second. Okay. Calculate, the hammer stops quickly when it hits the nail. The momentum of the hammer reduces to 0 in 0.07 seconds. Calculate the amount of force that causes this to happen. So calculate the amount of force. What do you all get?
22.14.
Yeah, you should get 22 to 23 Newton. There's a range of value there. Okay, anyone don't know how to do? Yes.
I got
Me.
221.43. I think the decimal is wrong.
You check the decimal.
I don't know how to do.
I don't know how to do.
Okay, so now you have, okay, Nicholas, you want to explain?
So I think
Just explain.
1.55 divided by 0.07.
Okay, so why we do that is because momentum equals to mass times velocity.
Alhamdulillah.
Okay,
I put
so
11.5 pula.
momentum, sorry, momentum equals to mass times velocity. That is the formula that was used. Okay, the formula at the top. Okay, so now calculate the amount of force. So we know that my moment, wait, just a, okay, so we have mass is 0.5 kg, velocity is 3.1. Okay, the momentum of the hammer reduces to 0 in 0.07 seconds. Okay, so which means I have, just a moment.
Nick, don't listen song already.
The momentum just now, the momentum just now was 1.15. Correct? Okay, and then 1.55 became 0 because reduces to 0. So momentum is 1.55 minus 0 is 1.55 lah, minus 0 because it came down to 0. Okay, and then I have the time was 0.07 seconds. Okay, so if I take 1.55 divided by 0.07, I will get 22.14. Can?
Yes, sure.
Sure.
Teacher,
Yes.
1.55 divided by 0.7, right?
0.07. There's 0.07 seconds.
Okay.
Okay. Just give me a moment.
Hey, Nicholas, this Edmund damn free, right?
Why?
Wait,
Nicholas, you
I'm
want to
having
talk?
some issue with my screen. Just a moment.
Why?
Okay, let's continue. Sorry, I had some issue with the screen. Okay, let's continue. Okay, as it enters the wood, the nail exits a force on the wood. At the same time, the wood exits a force on the nail as well. Explain how these two forces are related. Anyone?
So I put the force exerted by the nail is greater, therefore the nail is able to penetrate the wood.
The force exerted, say that again, force?
The force exerted by the nail is greater, therefore the nail is able to penetrate the wood.
Okay. Anyone else? Now read the question. It says, as it enters the wood, the nail exerts a force on the wood. But at the same time, the wood also exerts a force on the nail. How do these two forces relate to each other?
Is it something about collision thing?
Collision? No.
Explosion?
Is it the area and the pressure thing? I don't know. Area times
No.
pressure. But
This one sounds like that bullet example, but I don't know how to explain.
uh-huh.
Okay, so now, actually this is much simpler than that. It's just a very straightforward question. So if you see, the question says, as the nail enters the wood, the nail exerts a force on the wood. So the force is downwards. The nail is moving downwards into the wood, right? So the force exerted by the nail is downwards. And then at the same time, the wood exerts a force on the nail. So the force of the nail is downwards. The wood to the nail will be
Upwards.
upwards. So it's opposite. The forces are acting in opposite direction. One up and one down.
So
Okay.
this the answer.
Yeah. So you just have to say the forces acting on each other are opposite. On the nail to the wood is downwards. The wood to the nail is upwards. Okay. And this is related to Newton's third law. Does anyone remember what's Newton's third law?
Yo.
Okay, I ask you a question. See, the hammer is being nailed, the nail is being hammered into the wood. Okay, when you nail a hammer into the wood, are you pushing the wood towards the nail to make the nail go in?
No.
Wait,
No. But why
I
is
only
it
got
that the
Newton's
wood
second law.
exerts a force on the nail? If let's say you're hammering the nail into the wood, you're just hammering it in. You're not pushing the wood from the other side so that the nail will go in faster. But why is it that the wood exerts a force on the nail? Where is that coming from?
Pressure.
Not quite.
Where is the third law? Now right to go on.
So that's related to Newton's third law. So Newton's third law says every action has an equal and opposite reaction.
Ah.
So this concept, this behavior of the wood exerting force on the nail is because of Newton's third law. So Newton's third law states that every action has an equal and opposite reaction. So when the nail is being hit into the wood by the hammer, yes, the wood is not, you're not pushing the wood towards the nail also, but because of what Newton's third law says, that every reaction has an equal and opposite reaction, the wood is also exerting a force on the nail. Okay, so you must mention two things. The first one is the forces are opposite. So the nail to the wood is downwards, the wood to the nail is upwards. And then the second is this obeys the Newton's third law, which states that, then you have to state Newton's third law. Every action has an equal and opposite reaction.
Okay.
Unexpected. Then.
Lol.
So 2 points or 2 marks.
Just give me 1 minute to write everything.
Can.
Heck, 1 minute enough.
Please note there Newton's third law and write
Yes,
down
teacher.
what is Newton's third law as well.
Every reaction has an opposite reaction.
Every action
Every
has-
action has an opposite reaction.
has an equal and opposite reaction.
Okay.
Which means, right, the force exerted by the wood on the nail is also equal to force exerted by the nail to the wood. But why is it that the nail gets to penetrate the wood? Actually, the nail is sharper, a smaller surface area. But actually what we don't see is that the wood is also going into the nail, not just the nail going into the wood. It's just that we don't see it because we are hammering the nail. Because Newton's third law said that proves that because every action has an equal and opposite reaction, the wood is also actually pushing itself into the nail. It's just that we don't see it because we're hammering the nail. Okay, anyone has any questions so far?
No.
No, sir.
Okay, can I continue?
Yes, sir.
Anyone still writing?
No.
Mahak finish up.
Yes, teacher.
Okay. Okay, both ends of the nail exert pressure when the nail goes into the wood. Explain why the nail exerts more pressure on the wood than it does on the hammer.
Because the surface
Because
area
the
smaller.
smaller surface area.
Okay, so we are looking at pressure equals to force over area. We're looking at that concept. Okay, so the smaller area of the nail is in contact with the wood, which is why the pressure is greater between the nail and the wood compared to the hammer and the nail, because the nail at the top is flatter, the surface area is bigger, whereas at the end, the surface area is smaller. So when, according to the formula, pressure equals to force over area, the smaller the area, the higher the
The
pressure.
higher the pressure. Nicholas, can hear you playing music sound.
What?
Okay, anyone question? All okay so far?
All okay so far? Not sure.
Good job.
Okay, let's continue. Okay, a toy train is placed on the middle of the bridge on a model railway. Okay, 15 Newton. The weight of the train acts through its center of gravity. Ignore the weight of the bridge. Which row of the table shows the correct values for forces X and Y? Did I give you all, do you all have this as well? Did you all do this?
Yeah, sure.
Oh, it was in the questionnaire, okay. Which row of table shows the correct value for forces X and Y? Anyone?
A.
I go for A.
A?
A.
Yeah, so because this is the center, Okay, 15, so 7.5, 7.5. Half that. Okay. Describe how force X changes if the train moves from P to Q. So the train is moving from P going to Q, going in the right-hand side direction. What will happen to the force on X?
It will come higher. No, lower.
Come low.
Okay, so the force X decreases. Okay. So it will go from, let's say it starts here, right? So all the 15 Newton will be here. And then as it goes down, it will go to 0. Okay. Now the train is in the center. So the forces are balanced. But when it goes on one side and then it goes to the other side, it will go from 15 to 0. Okay, next. The diagram shows apparatus used to investigate moments. Okay, I have the pivot, 2 Newton weight, Newton meter, and meter ruler. The 2 Newton weight is placed 60 cm from the pivot. The Newton meter is placed 10 cm from the pivot. Okay, who would like to label on my screen these two readings? Label the 60 cm. So draw an arrow and label the 60 cm, and then draw an arrow and note the 10 cm.
Me.
Okay, try.
Check and just draw.
Yeah, just draw on my screen.
Oops, went out.
Good job. Nice.
My drawing skills out here is very bad.
Mahendra, see, the 2 Newton weight is placed 60 cm from the pivot. So the 2 Newton, the 2 Newton is 60 cm from the pivot. So you have to draw it where you're showing it's from the pivot. You cannot just label it like that. This is not 60 cm. Erase everything and do again.
From the pivot is 60 here. So like this, Acha.
Yes, but don't draw on the ruler. Draw outside the ruler.
I didn't draw on the ruler. I draw. That was someone else.
Don't fool around.
This is 60 cm.
Draw right on top of the ruler, or on top of the arrow.
On top. And then the Newton meter is 10 cm from the pivot. So, no. Like this?
Yes, correct. Okay, so this is not in the question, but I just wanted to make sure you all know how to label. Okay, next, state the equation linking moment, force, and perpendicular distance from pivot. Like previously, moment equals to force times perpendicular distance from the pivot. Okay, next, calculate the reading on the Newton meter, not the weight of the ruler. So what will the reading on the Newton meter be? What did you all get? Anyone? What principle are you using here? If you see, all this is balanced. Okay, so you want to equate a moment of anti-clockwise
Is
and
the equals to The moment
Correct.
clockwise.
Yes. Clockwise moment equals to anti-clockwise moment. Okay. So 2 Newton is with 60 centimeter. And then the weight of the Newton meter, which is what we want to find, is with 10. So if we equate it, you should get something like this. So 2 Newton times with 60, because force times perpendicular distance from pivot.
120. 120.
120.
Sorry, 20.
Oh, wait. No, correct. 120. No, before that, 2 times 60, that means one of it has to equal to the distance 10 times whatever force that is on the Newton meter. Because anti-clockwise moment equals to clockwise moment, because they are now balanced. Okay, so 2 times 60 is 120, is equal to 10F.
12. 10
what
times
is
12. 10 times 12.
So F is equals to
12.
12 Newton. Okay, everyone got that?
Uh,
Yeah?
Yes.
Okay. Beatrice, okay?
Yes.
Wingyan?
Yes, sure.
Okay. So you should get 12 Newton. Okay, next, the meter ruler is replaced by an iron bar. So instead of the meter ruler, you put an iron bar. The iron bar is 1 meter long with a weight of 10 Newton. The Newton meter and the 2 Newton weight stay in their original position. Okay, so everything else stays. It's just that now I use an iron rod, which is 1 meter long and 10 Newton, has weight of 10 Newton. How does this change affect the reading on the Newton meter?
It gets heavier because it's an iron bar.
Correct. So what will happen to the reading on the Newton meter?
you'll get higher.
Will
Correct.
increase.
Correct. So when you answer questions, you must be very careful how you answer questions. It says, explain how this change affect the reading on the Newton meter. So we have to talk about the reading on the Newton meter. So you say, the reading on the Newton meter is higher or increases, and then explain why. Then you say, because the weight of the bar
Will be heavier.
because it's iron. Okay, so this will mean that when the weight of the bar is higher, what will happen to the moment? Bigger or smaller?
Bigger.
Bigger, because higher mass. So this will cause the moment to be higher. So you talk about the Newton meter reading increasing. Why? Because the weight of the bar is bigger now, is more, because it's made of iron, and it has a larger moment. Okay? So it will move in the same direction as the 2 Newton weight. It will move down. Okay? The clockwise direction, because it's heavier. Because now I have 2 Newton, and then I have the 10 Newton as well. Okay, let's continue before we take a quick break. Okay, which of this is a unit of the moment of a force?
B or A?
B, yeah, B, Newton
Oh,
meter.
B.
Because moment
Okay.
is force times perpendicular distance from pivot, so Newton times meter, Newton meter. Okay, a painter set a uniform plank so he can paint a wall. The weight of the plank is 500 Newton. I have 0.5, 0.5, length of the plank is 3. The plank is 3 m long, weighs 500 Newton. Okay, so now use the principle of moment to show that the upward force A is 250 Newton. So basically you need to calculate 200, the upward force A, and show that it is 250 Newton. Okay, so we know moment is force times perpendicular distance from pivot. Okay, And we know clockwise moment and anti-clockwise moment is equal to each other. Okay, so
500 divided by 2.
500 times 1.5. Then you get 750, and 750 divided by 3. 2 equals to 250.
I did 500 divided by 2 itself. It will give 250,
Nice.
I think.
Yeah.
okay, Nicholas, can you explain your method?
Because I took 500 Newton, then I took the length of the planks times the 0.5 to get 1.5. So then after that, I took 500.
Wait, why length times 0.5? What did you do there?
So actually, I also don't know. So I just don't know.
Tembak ni. Like clear already. Tembak aja.
Itu sih simply pakai answer remember.
Okay, let's see. Okay, so now we have. Okay, anyone else wants to try?
Sure, 500 divided by 2 can, right?
Why are you dividing by 2?
Because it says 250.
No, you cannot simply say like that. You have to explain based on moment.
Okay.
Okay, Beatrice, did you manage to do that question? Beatrice, are you there?
Yeah,
Okay, did you manage to do this question?
not quite.
Not quite. Okay. Anyone else? Wing Yan, did you manage to do that? No, also. Okay, let's look at it now. Okay. So we know that moment is equals to force times distance. Okay. From perpendicular. Okay, now we know that the moment for clockwise equal to moment of anti-clockwise. Okay. So now on one side, we have 500 Newton times 1. Why times 1? Because 0.5 on this side, 0.5 on this side. So 1. And then I have an upward force, which we want to say that it's 250 times with 2. Why 2? Because the whole length is 3 meters. Minus 0.5 minus 0.5, I'm left with 2. So my A is equals to 500 divide 2. So you get 250. Okay?
Okay.
Okay,
So it was correct.
so if you see, I have the first moment, which is 500 times 0.5 plus 0.5, which is 1, equals to the upward force, A, okay, times 2. Why 2? 3 meter minus 0.5 minus 0.5, which is 3 minus 1, which is 2.
Okay.
Okay. Okay, state the value of force B.
250.
250 also. Okay, A is 250, B is also 250. Okay, the painter stands on the plank as shown. Okay, he stands on this side. The center of gravity is here in the middle. He's standing on this side. Draw an arrow on the diagram to show the weight of the painter.
Can I do that?
Yes, can.
Yeah, can you scroll up? Okay. Ah, oops, sorry. Here.
Yes, correct.
A very thick
Yeah.
line.
That is the weight of the painter. Okay. Let me just... Okay. So that is the weight of the painter. Describe the changes in force A and B when the painter stands on the plank. So when he stands here, what happens to the changes in forces A and B?
It becomes heavier.
It's
He stands on
higher.
the plank.
Okay, both forces will increase, but where is larger?
B.
At
B.
B or A? B,
B.
because he's standing towards B. Okay, so force at B is larger than force at A. Okay.
Yeah.
Okay. You can quickly go for a break. It's 9:50 now. Come back at 10 and then we'll continue.
Okay, chill.
Okay, let's continue.
Okay.
Okay, a student investigates friction between a block of wood and different types of surfaces. So we're looking at friction now. Okay.
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 Okay, it's very important when you start reading a question, right, to identify what type of question it is or what topic is related to, so that when you answer, you will be able to sort of know what kind of answers are they expecting. Okay. Yeah, just a moment. I'm just answering the chat. Okay, so the student uses the equipment shown in photograph A to measure the force needed to move the block of wood. Okay, moving this block of wood on a specific surface. Suggest why the student places masses on the block. Why do you think the student places this mass, this load on the block?
To see how much weight he can carry.
To see how much weight he can carry. What do you mean?
Is it because the wood is too light?
Sorry?
Is it because the wood is too light?
Increase
wood
the
Not quite.
Check, go back to the picture.
So imagine you're pulling the wood.
Oh wait, to see how strong the wood is when you pull the wood.
to see how strong the Newton meter is and how much weight it can handle. I don't know.
No, but why do you need to know how strong the block of wood is? We want to look at friction. What?
So that there's more
Yeah,
friction.
because the bottom surface of the wood.
Oh, they put it because they wanted to see how to explain it when you drag something.
I don't know how to
You want
explain.
to see what? Sorry.
To see like how to say.
It's so that the block is more friction.
Okay, so related to that, so the reason why is, so when you want to pull the block, right, you want to make sure that you don't lift the block up when you're pulling it up. So when you're pulling the Newton meter, you want to make sure that the block of wood doesn't like rise up. So you put the mass down so that it will keep the block of wood down, and this will also increase the friction. Okay, if not, it will be easier to slide. Let's say imagine you're pulling the Newton meter and then you tend to lift the wood up. Then you won't get the exact reading that you're looking for. So you keep the block of wood down. Okay, so to make sure that the test is fair. Okay, make sure that each surface when you pull the block of wood, it will be the only thing that will be different is the type of surface, because you don't want to do the test unfairly. Okay, so you're increasing the friction actually. So you want to ensure good contact with the surface. Can everyone hear me clearly?
Yes.
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 Gotcha.
Yes, Ja.
The statue is having, she says she cannot hear me, so I'm wondering if it's just her or everyone.
I think internet problem.
I can't seem to reply her so now. Okay, so now, why he keeps the mass constant during the experiment?
So it's a fair test.
Correct, so it's a fair test. That is why you want to keep that. So you cannot like use this one 2 weights and then another surface you go and use 3 or 4. Okay, so to keep the fair test, you make sure you put the same amount of mass. If 2 means 2, 4 means 4. Okay, the student investigates 5 different types of surfaces. So these are the types of surface. The table shows these results. Give an example of a non-continuous variable. Non-continuous variable means what is different. What is different here in this experiment? What is different? What is the variable that is different here?
Average.
What's the manipulated variable? What am I changing in this experiment? What am I changing?
The type of
Mass.
Type of surface. The mass is the same. The type of surface is changing. Okay, the type of surface is the one that I'm constantly changing, so it's non-continuous variable. It's another word for manipulated variable. Okay, so what I'm changing is the type of surface. What am I measuring? My responding variable is the
average.
force, the average force, okay, which is basically the friction, which results in the friction. Complete the table by inserting the missing average. So you should get 4.5.
5.
So you just add these two, and then you divide by 2. So it's 4.5. Display the average force results for this investigation on the grid. Okay, who would like to try and draw this graph? Draw on the screen.
Nick.
Try? Huh?
Not me.
Not you. Why not you? Okay, because you say not you, you shall try. Mahak, come.
Mahak.
Strawberry so bad at graph.
It's okay, I will guide you through it. Okay, so the type of surface is the manipulated. So type of surface is what is going to go here. So you write down here, chipboard, wood, cost. You don't have to write down the whole thing. You can just write C for chipboard, W for wood, and just put the initials lah. And then you want to draw a bar graph. Okay, because this is not numbers at the bottom. These are different kinds of surface. You want to draw a bar graph, and then you label your y-axis. You want to draw the average. So your x-axis is the type of surface. The y-axis is the average. Okay?
Okay.
It's going from 0.5 to 4.5. So you estimate lah. Maybe you can do 1, 2, 3, 4, 5, 6, and then you draw the bar graph accordingly. Okay, come draw.
Okay. So first I label them C. Why can't I write?
Use the pen.
Yeah, sure. It's just doing dots.
Oh, try a different color. Maybe it's not a.
So can you scroll down a bit? Okay. Yeah, sure. It's doing that.
Then what are you drawing?
Now okay. Now
I'm trying to see.
Okay. Now it's okay if you cannot draw properly. I mean, cannot write properly.
So this will be W. Good enough. What was the next one, Cha? What was the other ones? I forgot.
CS.
C. Yeah. Okay.
Yes.
CS.
Go.
S. I.
S and then I.
CS. FSI.
CS go.
Wow, that was
GG.
NX CS go is Counter-Strike Global Offense. Global what?
C.
That's Global Orange.
Take
That's-
you. I'll slap you.
Yes. Okay. Next is 1, 2.
Damn it, heck, you draw some 2 square, some 1 square. What you drawing?
Make sure your scale is the same.
Oh, that's why it's really.
You're using what?
Are you?
Okay. Now I do slowly.
Never mind. 2. This is not helping, but okay. So can you help me write the numbers?
Okay, let me write for you.
Thank you, sir.
Okay, someone has a radio on the background.
Nicholas.
Can you mute yourself, please? Okay, so 1, 2, 3, 4, 5, 6. Okay, write one here properly. Okay,
So C was what number?
okay, so wait, let me scroll up again. C is
3.
3.
so for bar graph, do you have the straight? Use the straight line.
I have an arrow.
Oh, okay. Try and see.
So can use square rectangle also, I think.
Yeah, that's what it does.
Oh, how? Okay, go under draw. Do you have other options? Straight line.
And
boxes?
arrow, color, erase, and clear.
Oh, okay. Okay, never mind.
Don't have rectangle, man.
Don't have.
Don't have.
Oh,
Okay,
okay.
never mind. Who's drawing this one?
Show me.
Okay. Okay, never mind. Okay, Nicholas, continue.
Ah!
Oh, thank you.
Oh!
Because Mac don't have the drawing thing.
Joe, where's my mouse? I actually gotta see my mouse.
Hey, make sure all the bar graph is same size. If you're using one box means one box, two box means two box. So I have 3, and then the next one is, do you remember the units, the values?
Sure, I think so.
Yeah, can you scroll up? I'll write it down for him so I can tell him.
Okay, wait, Nicholas. 3, 2.5,
4.5,
4.5,
5.7,
5.7, and 0.5.
Okay, sure, I got it down. Okay, Nick, what are you doing? CS 4.5.
2, 4, 6.
There.
Hey.
Too long. Nick is stressing out. Okay, 5.7.
Oh my god.
It's cool. It's cool. It's okay. We'll erase that later. Next one is 0.5.
Okay, done.
You forgot CS, which is 4.5.
Hey, what you guys doing, huh?
We all are working together.
Ayyo.
Okay.
Okay, nice.
Okay, yeah. Just this part, right? Wait.
A bit cacat lah.
So
Not a bit so.
my FS will be here, and then my I will be here. Yeah. Okay, so you should have something like this. And you must label your axis. So what will be my x-axis?
The
Type of surface.
Type of surface.
So this is type of surface.
one graph looks like inside another graph.
Okay.
It's okay, Lohendra. Stop judging us.
And then the
Hang on,
y-axis is, what is the
Average.
y-axis?
Average.
Maya.
What's the y-axis?
Average.
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 Average, what is the unit?
Average.
Okay.
Why got another average? So look,
Okay. You should get something like this.
What should look?
Salute.
What lah?
your name Saluk, right?
Okay, let's continue. Shh. Okay, the student compares his results with others in class. He finds that they have different values for the forces. Why?
Because
They may have pulled with different forces.
Okay.
One may have pulled in a stronger force, one may have pulled in a different
Yeah,
force.
this is what I said, bro.
Explain in detail.
Because different people have different strengths, they use different force to pull. Maybe some of them, they use different mass, different weight on top. Instead of 2, maybe they use 4 or 6. What else? Maybe some of them made a mistake. They did not read the Newton meter, the force meter, the Newton meter correctly.
Different
Some
length.
may have pulled on top of a table.
Where else?
The table. What do you mean?
That one is they put on the floor, right?
So they put a different weight.
No, they put on the table.
Yeah, so different weights, and then maybe the
Different
surfaces were
different
not the
size
same.
of wood.
Yeah, different size of wood,
Different length of wood.
different
Actually,
length.
they're using the same type of wood all the time.
can I
No,
go?
they
I was about to say different, but then I was like, no.
No,
because
they
they're using
didn't
the
say
same.
because they just said you compare results with the others. You have
Yeah lah,
different values.
Lohendra.
What do you think would have been different? If they say they did the exact same thing, then that's a different story lah. That means you cannot use those things. But they didn't say those things, so you can put that as some of the suggestions.
Okay, Shelo, you don't have to scold.
Okay, next. The student repeats
People
the
make mistakes.
Huh?
Okay, the student repeats the investigation using another block of wood. Okay, different block of wood as shown in photograph B. And then I have the masses. The block of wood has the same mass but different area of contact. So same mass with the previous one. Okay, but now they have now it's bigger, it's larger lah in terms of the width. Okay, so if the area of contact is different. Explain how this change affects the pressure on the surface.
Larger surface area results in lesser pressure.
Yes, I was about to tell that.
The pressure will be
Whatever.
lesser because the area is
Bigger.
larger, using the formula pressure equals to force over area lah. Okay, Suggest 2 ways in which the student could reduce friction between 2 surfaces.
Lubricating oil and use a just lubricating oil, I think, yeah.
Okay, so you can use a lubricating element between the 2 surfaces. You
Put
can make
wheel
the
there.
you can make the surface smoother. Let's say sandpaper the wood, make it smoother. And then you can also decrease the weight, because they put weight to increase friction. So if you decrease the weight, that might also decrease the friction. Okay, decrease the
Sure.
mass.
Put 4 tire.
Or you can put some sort of wheel to make it smoother. Yeah.
Huh? But adan saya nggak friction. What?
But it's easier to move what?
Salut. Hai kami beda kan ayah.
Okay, anyone has any other answer?
So use a roller.
Yeah lah. When he said tire, I meant roller lah. Same thing.
Wow.
Okay, but the only thing with putting rollers is that might cause the wood to not touch the surface.
True.
Not those big tire.
That's the only. You put a roller or a tire or anything, that will lift the block up, so the block will not be touching the surface. So then it's a whole different experiment. Now you're looking at between the tire and the surface.
Hey, stop laughing lah.
They shush.
Okay, anyone has any questions?
No, sure.
No?
Yeah.
Okay, then that is all for this paper. Okay, and then I had a request.
Quite
Yes,
hard.
but before that, I have a request to do, someone requested me to go through moments one more time.
Okay,
So I'm
sure.
just going to go through that topic. So just give me a moment. Just give me some time. I'll just find the slides and then we will just go through that.
Okay,
one-
sure.
Okay.
Yeah, can I go pee in the meantime? Yeah.
No.
I will. You can go take a drink or something. I will see you for the slides. Yes. Yes.
Hi.
Oh, hi. What? I think you said hi, so I was waiting for you to complete your sentence.
Salut, come I show you my dog.
Where? Why are you
Huh?
showing yourself?
Very funny. Come here.
Where your dog?
Wait, he must come up.
Lorinda, come out.
Hey, quiet lah.
Cepat lah.
Come. This guy don't want to come up, so wait.
Oh, carry lah. Aiyo, this Lorinda.
Cat.
Scared dog bite you.
Hey,
Like my hack only.
oh my god, is that Chihuahua? Chihuahua.
Where? Carry up again?
Okay, so we're going to look at it. Today is a bit, the slides are different, but it's the same topic, conservation of momentum. Okay, so what we're looking at is what happens. We want to look at what happens when 2 objects collide, and then we want to calculate the momentum before and after they collide. Okay, so we're looking at what happens when 2 objects hit each other, and we want to calculate the momentum before and after they collide. Okay, so conservation of momentum. Total momentum of a system before a collision is equal to the total momentum after a collision. So that's the principle of conservation of momentum. Momentum is conserved. Like conservation of energy, before and after is the same. They are not destroyed. They are just transferred. Conservation of momentum is total momentum before a collision is equal to a total momentum after a collision. Why? Because it's the same concept with energy. Like nothing is destroyed. It's just that one is transferred to the other. One is more and one is less, but it's the same in total. Okay, so momentum before collision is momentum equal to the momentum after collision. Okay, so let's look at this. Moving trolley and a stationary trolley. Okay, stationary trolley means it's not moving lah. And the moving trolley is 0.5 kg moving at 1.2 meter per second. The other one is 1.5 kg and then I have 0 meter per second because it's not moving. So they stick together after the impact. Okay, so A's momentum is mass times velocity, 0.5 times 1.2, which is 0.6. Okay, and then B's momentum is 0. Why? Because the mass is 1.5, but the velocity is 0. Anything times 0 is 0. Okay, so total momentum before collision is 0.6. The momentum must remain the same after the impact. So after impact is also 0.6. Okay, so let's look at this. It's the same thing. So after the moving trolley, they stuck together because the question says that they stick together. So what happens is, now the mass is, the total momentum before was 0.6. Remember, momentum is mass times velocity. So total momentum divide total mass is equal to the velocity, because momentum is mass times velocity. Velocity is momentum divide mass. So momentum is 0.6 divided by my mass. My mass is now both together, the trolleys, 0.5 and 1.5, which is 2. So 0.6 divided 2 is 0.3. So the velocity is 0.3 meter per second. Okay, everyone understand so far? Any questions?
No, sir.
No, sure.
No? All okay? Okay. Tachu, can understand?
Yes, teacher.
Okay. Okay, now you try. Okay, all of y'all try. I have a mass 40 kg, velocity 0, 160 and 5. What is the momentum of the rugby player before the impact and the speed of the two together after the impact? So let's say this fellow go and hit the small boy and both also fall. So what is the speed of the two together after the impact? Okay, I'll give you all a few minutes. Quickly try and then we'll discuss.
40, 0.
Teacher, I said 20 meters per second.
Okay, I have 20. Okay, wait for a few more people and then we will see.
Okay, sure.
Teacher, can you go back to the first slide?
Which one?
The before slide.
This one?
This one, yeah.
Okay, can I change
Okay,
the
sir.
next one?
Yes. Is it 4?
Okay. Okay, I have 4, I have 20. Okay, I'll wait for one more minute, then we'll look at the we'll look at how to do.
Is it 12?
Okay, let's see.
Yay.
Okay, rugby player before impact is 800 because 160 times 5. The two of the speed together after impact is 4.
Yay!
Okay, anyone don't know how to do?
Hank, do you understand?
Mahak, do you know why you got 20 and not 4? Do you know what's your mistake?
Yeah, I divided it at first. I didn't times.
Which one you divided?
I did was 160. Wait, what did I do? I did 160 times 5, which was 800. Then I divided it by 40.
You take 160 times 5, so you got 800, and then you
Yes.
divide it by 40.
Yes.
You're supposed to divide it by?
Both the mass.
Yeah.
What are you supposed to divide it by, Mahak?
Both of the mass.
Yes, because 2 together, you have to add the mass together. So 800 divided by 200.
Okay.
Okay, next one. Everyone try?
Okay. Find the momentum.
One.
Sorry?
One.
1.
Yes, teacher.
Okay,
That's a 1.
let's see. So what is the momentum of each of the skater before impact?
2000.
The peak is 8,000. The
8,000
rhino is
negative
negative
6,000.
6,000.
Okay. Speed of the two after the impact?
8,000 plus negative 6,000 equals to 2,000. Plus both the mass equals to 2,000. So 2,000 divided by 2,000 equals to 1.
Correct. Okay, very good. Okay, next one.
Yay. Yeah, I think I've seen a this. Five.
Jay, is it 28.5?
28.5. Okay. Let's wait about a couple more minutes and then we'll see what the rest get as well.
Okay.
28.5.
28.5.
Okay, let's see. Okay, what is the momentum of each of the skater? So each separately, you just times them together. The speed of the elephant if the penguin goes 50 meters per second after the impact. 27.8. Do you all get that?
Yes.
You all got 27.8?
28.5.
28.5.
Yes.
Okay, let's look at it. I have the speed of the elephant if the penguin goes 50 meters per second after the impact. So I know that the momentum before is equal to the momentum after. Okay, so the speed of the elephant if the penguin goes 50 meters per second after the impact. Okay, so the penguin is 50 meters per second after impact with a mass of 120 kg. Okay, let's see.
I got 28 or so.
After round up or you just got 28?
28.5, sir.
28.5.
Yes.
Okay. Let me see.
105,000 plus negative 18,000 equals to 10320.
How did you all get 28.5? Can you all walk me through it?
So you take the 105,000 plus the negative 1800. You get
Okay.
103,200.
And divided by
Then divide by 3,620.
they get 28.5, sure.
Yeah.
So you take the momentum, you add them together,
Yes.
you get 103,200, correct?
Yes.
That is the momentum before.
Oh,
Okay.
Huh?
That is when I add both the momentums of each of it together lah. And then you divide it by what?
3,620. Because you
3,000.
plus both the mass.
Yeah.
But the question now says if they don't stick together.
that means
So how would you do that? If they stick together, then yes, you add the mass together. If they don't
Then
stick
you
together,
do separately.
okay, do
then
separately.
minus.
Do separate.
Go and
So
see.
the 103,200 divided by 3,500. What elephant separately? I got 29. Let me just try the penguin. Nope, I did not get 27.
I got 2.9.
So
2.9.
try to think. They don't collide together, so they don't stick together. And then the penguin goes 50 meters per second after the impact. So what will be the speed of the elephant?
Here.
30 plus 50.
Check and teacher, I don't know.
Okay, wait, think for a while. Think for a while, then I'll teach you.
Penguin goes 50. Not very fast. The only thing I can see that the elephant slowed down. And the penguin increased its speed.
Okay. What else? Think about it. You have to imagine it a little bit.
Think of an elephant and a penguin skating.
Ja, can give me 5 minutes, Ja. I'm gonna go do something.
Can.
Okay.
Nicholas, do you have any idea?
Hold on.
Apa ya bang?
Nice.
Yes. Sir,
Yes?
the momentum after the impact is also the same, right?
Yeah, because conservation of momentum states that.
Hmm.
So the situation is the elephant and the penguin. The elephant hit the penguin. Okay, and then instead of they sticking together, what happens is the elephant hits the penguin, and then the penguin goes 15 meter per second. The penguin goes, it speeds up lah to 15 meter per second after that.
So 15 minus negative 15 plus 50. Yeah.
I got
Which one?
35. So try negative 1800 divided by 35.
Negative 1800 divided by
35 because negative 15 plus 50.
negative 51.4. It's even worse.
Okay, even close. Now even close to 20. You 105,000 divided by 35. Not even close. 35 T is 65.
Before is what? What is the momentum before?
It's the same as momentum after.
What is momentum before that?
Sorry. Which one? The elephant or the penguin? Like that.
Yeah. Add together. Lah.
Add to. Oh, I never thought of that actually. You know, I didn't see one of that. Oh, still not close.
Wait.
I got 1587.
Yes, I got negative 2.9. Negative 294. 2900.
2948 right?
Why are you crying, lah?
I don't understand.
Both of you are so talking confusing. I don't know what they're doing also now.
Hey, you will never know what you're doing.
Point. But right now I'm getting really confused.
When are you not?
Try doing, you get more confused.
Yeah. Then you'll start crying.
Just discuss, teacher.
I tried plussing the speed together and dividing.
I just
Still never
passed
come.
Yeah. Velocity is speed plus negative 35. Negative 5.
What if we plus the mass? I
Good
plus
idea.
the mass.
Try that. How about that, huh?
3620. Okay.
Divide by negative 5. No, I get 3615. No.
Are you?
Okay, Cha, I'm back.
Okay.
Congratulations.
Everyone is
Give
still
up, teacher.
They cannot give up.
3500 plus 120. Okay, then this divided by this. I got negative 27.
What? Okay, Mac. What did you do? Okay, tell me what you did.
I did 6. Wait, 1 second. I forgot the number. 120. Okay. 3,620 divided by what's that?
20,620.
3,620 la Lohinda.
Okay, sorry.
Chill.
Right. You continue.
Then I divided by negative 15, which gives you 20. What?
What?
Wait. Oh, it was. Sorry, it's my bad. It was 2,700.
That's from just now you are getting right.
My head.
It's 271.
Hey, Salu, you don't laugh, you do. You do what you understand.
Okay,
So
guys.
big difference, you can
Now,
see wrong.
You, have to, okay, you cannot simply take numbers and divide and try to get 27.8. You have to imagine it. Okay, what is happening? And let's say the elephant hit the penguin. The penguin moves 50 meters per second. Now they're asking what happens to the speed of the elephant. Does it slow down? Does it move faster? And so you got to think about that. You cannot just take numbers and try to divide.
The elephant bounced the penguin back. And the penguin went flying. But the elephant looks like it's gonna fall down.
Elephant
Okay.
fall means the ring also cracked.
Yo, my brain susah. Sakit.
This is a math class already.
You see number of course math class lah, what else?
This one worse than math class.
Hey.
45. I got 10.69. How is that even?
Mahak, just stop trying. Let's explain.
No, I'm not going to explain first. You all have to figure it out first.
What?
Exactly.
Okay, Cha, I got 27.8.
How?
Yeah.
How kita lah, how?
Just same as your explanation.
He didn't explain
I'm
anything.
going to explain anything.
Just give me a fun.
What?
With my brain. I'm just going to mute everyone.
How are you gonna meet everyone? You only can mute yourself.
Shut up for 5 minutes.
Nope.
Nope.
Negative 15 plus 15.
And if they don't stick, stick bola. What is the momentum of each of the atoms on the spectrum? I give up.
No. No, you got 28.
Smell cockroach.
You smell yourself? What?
Cockroach like you.
Sorry.
Faster,
I didn't
finish
get
or not?
Oh no.
No.
I got 30.
Congratulations. Hey, do 30 minus
3.
30 minus. Do 30 minus. Wait 1 second.
30 minus
30 minus
negative.
2.2. That you do 30
Yeah,
minus
yeah.
2.
Yeah. From where you get the 2.2?
Yeah, you simply tell 2.2. Where you got?
I got
Simply.
it by 30 minus
Simply,
10.8. That's how I got 2.2.
simply put your number, heck.
Where do you get the 2.0 from?
Yeah, I got an explanation. How did I get 2.2? I did 30 minus 2, 7.8. That's how I got
From where
2.2.
you get
2 7.
27.8?
That is the answer you're supposed to get. You
Yeah.
can't use that number.
Minus
You
that.
can't use that number. My heck. Stop, my heck. Susah lah, my heck. Susah.
I have an explanation. I'm just saying.
Apa?
They should have stopped laughing and actually work on something.
Okay, guys, I give you all
But
a
if
hint. Shall I give
Okay,
you all
yes,
a
yes.
hint? Okay, please listen to the hint. Okay, so again, if we look at the previous questions, okay, all these questions they stick together. Okay, so and then if I look previously, okay, this one. Okay, I take the total momentum, and then I remember momentum equals to mass times velocity. Then I take the total, remember, principle of conservation, before momentum equals to after momentum. Before collision equals to after collision for momentum. Now, the difference is these trolleys, they stick together. So my total mass is, I just total up the mass, which is 2, and then I take the momentum and then I divide, and then I'll get the velocity for both. Why I don't have to find the velocity separately? Because they're sticking together. But now, they don't stick together, which means they're going to have different velocities at the end. So my total momentum before collision, again, is still equal to total momentum after collision. But now, I cannot add the masses together. I cannot add the mass of the penguin and the elephant together because they are not sticking together. So they are separate with separate velocities. But momentum before collision and momentum after collision is still the same. So the clue here is I cannot add the masses together. I need to calculate the momentums after collision separately. So try again.
Oh. Sir,
Yes?
must we plus the momentum and then divide the mass separately?
You plus the moment. Okay, what is the momentum before collision? The total momentum before collision.
103,200.
Okay. Now let's look at after collision. After collision, I said that the tip is I
The
cannot
same.
add the mass together. So I must look at them separately.
Okay.
Okay. So if I look at the elephant, what is the momentum for elephant after collision?
103,200 divided by 3,500.
No. What is the momentum? What is the momentum of the elephant after the collision? How to calculate
3,000
momentum?
3,500 times 30.
No, after collision.
After
What is the
collision.
velocity? What is the velocity of the elephant that after collision?
105,000 minus 10. What?
Read the question.
30 meters per second is the velocity.
After collision. Before collision is 30. After collision.
Plus 5. E plus 50.
Read the question.
And the speed of the elephant is depending on
So what is the speed of the
After
elephant?
Minus 50. I don't know.
Hey, read the question properly. You're supposed to find the speed of the elephant. So what is the speed of the elephant?
27.8.
What is the speed of the elephant?
27.8.
What you get?
Where you get 27.8 from the question?
Yeah. You
Okay, never mind.
just now answered that right nicely.
What is the speed of the elephant from the question?
From the question,
30 meter per second.
After collision.
after collision, like after collision.
80 meter per second.
Hey,
Does it
read the
want
question.
5,000?
50 minus 30.
I tell you
Fif-
now.
15.
No,
Hey, that's the penguin lah.
15 is penguin. Okay, guys, again,
Elephant,
I'll
why
go
you
step by step.
torturing me?
Go step by step. Okay, look at it before collision first. Okay, before collision, what is the mass of the elephant?
3,500.
Correct. What is the velocity of the elephant?
30.
330.
Okay. What is the mass of the penguin before collision?
120.
Velocity?
Negative 50.
Okay, so this is all before collision. Now let's look at after collision. What is the mass of the elephant after collision?
After 3,500.
Okay, what is the mass of the penguin after collision?
120.
1,200.
What is the 120? What is the speed or what is the velocity of the penguin after collision? After the
50.
impact?
50.
What is the velocity of the elephant after the impact?
Negative
20.
20.
Where are you getting 20 from?
I don't know. 30 ah.
No.
I don't
After
know.
the impact, what is the speed of the elephant?
Negative 15. See.
No, that is no.
No, I took
Negative
the difference between the 30 and negative 15.
Hey,
Negative 20.
the question says find out the speed of the elephant after the impact. That means we don't know the speed of the elephant yet.
Wow.
Everyone answering.
Sir, you were asking Larry as an answer, sir. We're answering.
No, you're supposed
You're supposed to
to
find out.
tell me. That means you're supposed to tell me that you're supposed to find out lah.
Oh,
Oh, yes, yeah.
There's no answer. Everyone's simply answering.
Okay, so the speed of the elephant is what you're supposed to find. Okay, so now let's look at it. Before collision, what is the momentum of the elephant? 105,000. Before the collision, what is the momentum of the penguin? -1800. So what is the total momentum before collision?
103200.
Correct. So remember, before collision equals to after collision. So 103200, which is before collision, is equals to
103200.
After collision.
the momentum after collision. Now, after collision, what is the moment? Now remember, the animals did not stick together. So you have to calculate them separately. So what is the momentum of the elephant after collision? So 3,500 times, what is the speed?
30.
After collision, what is the speed of the elephant?
Nothing. Don't know.
Nothing.
Don't know.
Yes, that is what you need to find out. So you put X.
Apa?
Okay, add with the momentum of the penguin after collision. What is the mass of the penguin?
120.
Yeah, 120. Sorry.
0. What is the velocity of the penguin?
Negative 15.
They after
50.
collision.
50.
50. Okay. So 103200 is equals to 3,500x plus 120 times 50 is 6,000. So that is your equation. 103200 is equals to 3,500x plus 6,000. So find for x.
Tell again. Sorry, I
I got the
couldn't hear.
equation. Yeah, I got the equation, but after that, I did the calculation.
Can you repeat again?
So the equation is 103200 is equals to 3,500x plus 6,000.
1.71.
You bring the unknown to the other side first.
Yes, I'm going to send a picture on the group.
6,000.
Okay, everyone look at the picture if you don't know what I'm saying.
And then you bring this one.
Okay, let me write it down here in another slide. If you can't view your phone. So, momentum before collision. Momentum before equals to momentum after. Okay, momentum before is 3,500 times 30, which is the elephant, plus with 120 times 15, negative 15. This is for penguin. And this is equal to after. After collision, the elephant is still 3,500, but I don't know what is the speed. I put y here because x is already times, plus with
The penguin speed.
penguin, which is times 50. See, the difference between the questions before and the questions after is, this question I cannot add 3,500 with 120 because they don't stick together. The other questions, you added the mass together and then you just find the velocity straight away. So now 3,500 times 30 plus 120 times negative 15 is 103,200. That is equals to 3,500y plus 6,000. And then you use maths, 103,200. Bring the 6,000 to the other side is equals to 3,500y.
Yes.
What is that?
I got 27.8.
Yes, you are right.
Yes.
Because
Fine.
you tell everything ready, don't worry.
Yeah.
Yeah.
Yes.
Okay. I mean, I got my before teacher told lah.
Okay. So y is equals to 97200 divided by 3,500. Everyone can see me typing, right?
Yeah.
Yes.
Y is equals to 27.8 meter per second. Understand?
Wow.
Yeah.
Nice.
Nice.
I can't believe that was just all.
Yeah, we were just talking.
So I still follow the principle of conservation of momentum.
Nice, I
Just
guess.
that I don't add the um, masses together. Like the previous ones, you add the mass together. You see, the total mass is 2 because they stick together. So you can add a mass. But this one, they don't stick together. So you don't add the mass. You still put it separately. Okay? Okay?
Cha,
Yes.
can you give us like the question you gave us last week, the revision ones?
The one that we discussed just now?
Yeah, like those type
Sure,
of
but don't
questions.
give so much, Acha.
Yes, please.
No, Cha can.
They can give like this, ah. They can give like this, ah.
This one
One
nice.
I'm gonna knock your head.
Yeah, like this, sir.
This
The
one
one where you don't
only one
need
a
to.
lot.
Okay, I will upload on Edmodo. And then we will discuss in class again.
Okay, Cha.
Okay? Okay,
Yeah.
that
Yes,
is
teacher.
all for today's class. Thank you, class. Any questions, anyone?
Thank you, Cha.
No, sir.
No, huh?
No, Cha.
And that
Thank
is
you,
all for today.
Cha.
Thank you. Bye-bye.
Bye,
Bye-bye,
Cha.
sir.
Cha.